Hello. Thanks for having me. So my name's Fraser Innes. I'm the BIM Information Manager for Amey, and I'm currently working on a project called Wales and Borders Core Valley Lines Transformation. So if you know where Wales is, just leading north from Cardiff is a bunch of railways that we're electrifying. It's about 170 kilometres, as well as doing station upgrades and new depots and all that sort of stuff. The title of the talk is PIM to AIM sequence. So just to give you the lingo, PIM, Project Information Model, AIM, Asset Information Model. And this is a point in the project at which I'm currently at with the client, Transport for Wales, which is talking about really the objective of BIM Level 2. And that's making the PIM into updated to what's being built to become that digital twin or that asset information model, and making it ready to move into the ops data source so that the ops and maintenance crew can start to use it. So I wanted to talk about that sequence. A big part of it is ensuring that what's being designed has been built accordingly. And so to help with that venture, we talk about the as-built stage. There's really three components to the as-built stage. You have the red line markups, you have the as-built surveys, and it's those two things that are used to update the AFC or approved for construction model and drawing to what we call the as-constructed model and drawing. It's the CREC, or the building contractor, that's responsible for the red line markup, providing that to the design teams. And it's also the same responsibility for them to provide the as-built survey. Red line markups, if you're not familiar with them, they're essentially the AFC drawing that's used on site and marked up, typically in biro, as to any changes as to what they've done that's maybe different to what was designed. And that gets supplied to the CRED and the DPE for them to review. The as-built survey, there's nothing unique about the fact that it's called as-built. It could be a number of different types of surveys, whatever serves the purpose of capturing what's been installed to what was built. In the case of railways with track, the survey will often be in the form of a lift and slew table, which is just taking account every metre interval along the railway, that the coordinates of what's been installed is the same coordinates as what was designed. And that's fine as a survey, because we can import that and reproduce that line string. Things to check, and we've struggled on it on our project, and everyone does, is what's in the different suppliers' contracts. So, as well as it being the responsibility of the building contractor for the red line markups and the as-built surveys, in terms of doing that as-constructed model and drawing update, if like us, Amey's acting as the managing agent for TFW, we have 20, 30, 40 designers all working, building different parts of the jigsaw puzzle. If their contract ends after AFC, someone's got to pick up their work and update it to as constructed, and that can cause some complications in terms of liability of who's taking ownership of what. So try and avoid that if you can. In terms of doing that update, the most important thing that I try to get across to everyone is everything gets built a little bit different to what was designed, and that's okay, that's normal. All that really matters is, has what's been built within design tolerance? And if it has, really there shouldn't be much of an update to do, because we're just creating a digital twin or an asset information model for ops and maintenance purposes. Millimetre accuracy, I don't get hung up too much about. It somewhat depends on the discipline that you're talking about. So every discipline will have a different tolerance of what that design tolerance is. But here you can see 5 outcomes that I leave the design teams to consider. So they will open up their AFC models and drawings, revise them for this last work stage leading towards as constructed, reference in the as-built survey, look at the red line markups, and then decide what's applicable. If it's within tolerance, there isn't much of an update to do. There's a few administrative things to make it ready to be used post-construction. So that would be your first outcome. Your second outcome is where, hopefully, if something was installed different on site, you knew about it in advance. You knew about it either through a TQ or a field conformity notice or an NCR, which I've forgotten right now. Sometimes it does happen where things are a little bit different and you didn't get formally notified, and you've got to make a decision, well, do I approve it? But number 4, crucially, all design teams should have a say in whether they accept or reject what's being built. And if like number 4 says, if it's out of tolerance and you as the designer don't accept it, you should be free to reject it. 5, hopefully, doesn't happen too often, but for us, if something's fundamental has gone wrong, we may well want to go back a design stage if it has particularly a knock-on effect to other disciplines. One thing just to point out is on our project, on the Core Valley Lines project, we have about 65 PIMs, because it's quite a large area. So these are federated models. And PIMs are not workstage specific, and that's intentional. So PIMs will hold models that are at approving principle. They'll hold models that are at AFC or going towards AFC, and they will continue to hold models that are becoming as constructed. And I say to designers, you need to be comfortable with reviewing models alongside other models at whatever maturity they are at, and think not only about the interdependencies between your discipline and another discipline, but also what the maturity is of that. And the way that we manage it on the Core Valley Lines is we will have tracker spreadsheets for each PIM that lists all the models out, what the work states are, and what the maturities are, so that designers can make those decisions. Just adding on to that point, because on design and build projects, everything's at different stages. When it comes to getting all of that information, not just your models and drawings, but the documents and such, ready for handover or handback, and the compilation of the health and safety files, it's not practical to do it neatly because not everything is finishing at the same time. Everything's finishing at different times. And if you just waited for everything to be finished, you'd run out of time. In the railways, we use Bentley products, and so what you're seeing here on screen is a snip from ProjectWise, which is our common data environment. It'll probably be the same in other things like BIM 360, but one thing that we found really useful is DocSets, which allows you to link files, whatever the maturity is, into a container. And so we apply the same philosophy for the health and safety compilation. And what we've agreed with the client is, unlike health and safety files a long time ago, which used to be like a physical folder, and I want to explain what health and safety files are, just for people that don't know. It's not really so much to do with health and safety, it's just a term that's used in construction that describes all of the information associated with an asset in relation to the project works. So it'll be your drawings, your reports, your test certificates, and so on. And so what we've done with our client Transport for Wales is we've gone about setting out, again, about 65 health and safety files or sets of folders based upon geographic areas, which nicely for me is the same geographic areas as the PIMs. And that's what you can see here described in railway speak, which is ELR and mileage. And then we can start to, in advance of the end of the project, link all of that information through the DocSet system into those folders. For the actual handover, we've managed to nicely agree having the client to continue using ProjectWise for their health and safety storage. And so they've got a separate ops and maintenance data source. And I've found through testing it's quite easy just to copy and paste from our project data source into theirs. So that's what's going to happen. So lastly, let's talk about use case. And this is really what the ultimate aim of BIM Level 2 is all about. Having a usable virtual model or asset information model so that you can integrate physical and digital work and activities. On the CVL, we're using Maximo to manage all the maintenance regimes and works orders. And in the top left-hand corner, what was the PIM Federation map, which is used to manage all the PIMs, that will become the AIM Federation map. And we can link into all those geographic areas all of the health and safety files that are on ProjectWise. In terms of actual use case, one of the big things is about virtual walkouts. So rather than walking miles and miles of track and discussing what work may need to be done, being able to virtually drive down a railway and not just see the sorts of things that you might see if you were physically there, but other things that are in the model that won't be physically there. Things like buried services. Let's say you wanted to install a new line side of equipment, and you were wondering what that cable route might be. Being able to look at the virtual model and see those cable routes, see some of the sizes of foundations under the ground, and be able to plan out exactly the best solution before you've even got to site is definitely saves a lot of time and money. Then there's other things like signal sighting, driver training, and so on. But one thing that Transport for Wales are particularly interested in is savings that they might make for new projects. So a big part of a new project start typically is the cost and time of capturing surveys. So we're moving into this new world now where many infrastructure projects, particularly in the UK, will have been developed into AIMS. And so as designers, I'm looking forward to now where when I come onto a new project, it's not about a huge rush to get lots and lots of survey, but it will be more about having a data cut of an asset information model where the surveys that I will be doing will just be validating what is in that asset information model. That's a big saving. And then I can utilize or repurpose my time more into manipulating of geometry and manipulating of assets because the geometry is already drawn rather than drawing from scratch. And then starting to spend more time on 4D and 5D. So actually, planning, sequencing, scheduling of construction work and exporting geometry into schedules for costing and such. So that's my presentation. Thank you very much.